Now we're going to talk about aqueous solutions, which involve things that are dissolved in water. So in order to discuss aqueous solutions, we have to talk about our friend Arrhenius. And so Arrhenius came up with different theories for various things. He's the same person that did the acid and base descriptions or definitions, and it's really based on his theory of dissociation. So dissociation basically happens whenever ionic things that are soluble dissolve in water. So the more ions that are present, the better something will dissociate, and in turn, if it has charges, the better it's going to conduct electricity. Okay, so here's an example of how this might work. If I had solid NaCl and I wanted to convert it into aqueous NaCl, where it's dissolved in water, okay, what's happening is in the solid form of sodium chloride, if you kind of zoom in here, you can see all of the little ions, right? So these gray spheres represent the sodium ions, and these greenish, bluish spheres represent the chloride ions. And they're very nicely packed, one after the other, after the other, after the other, right? Sodium ions, chloride ions, sodium ions, chloride ions, sodium ions, chloride ions. And they're all together, okay? But once they start to hit water, then the water actually breaks them apart. And so they dissociate and they separate from each other. And so that's what's happening down here. Okay, I have one little sodium ion down here that is being surrounded by water molecules. And over here, I have a chloride ion that's also being separated, or surrounded, excuse me, by water molecules. And I can have different numbers of molecules surrounding each of these different ions. It doesn't really matter for our purposes, but let's say that the sodium ion maybe has 3 water molecules surrounding it, and the chloride ion has maybe 4 water molecules surrounding it. Because these things have ions, they can conduct electricity because there are charges. And so we can consider these things to be electrolytes. And there are 3 different types of electrolytes. There are strong electrolytes, weak electrolytes, and non-electrolytes. Okay, and so strong electrolytes are things that dissociate completely. These are typically very strong acids and very strong bases. So now you say, all right, who are the strong acids and who are the strong bases? Well, strong acids are things like HCl, HBr, HI, nitric acid, HNO3, sulfuric acid, H2SO4, and perchloric acid, HClO4. Strong bases are all of the hydroxides from the alkali metals. So things like lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, and then the bottom part of group 2. So calcium hydroxide, strontium hydroxide, and barium hydroxide, but not the top part, so not magnesium and not beryllium. Weak electrolytes conduct electricity to a small extent, maybe a few percentage points or so, but not very much, compared to strong electrolytes where like 99.9999% of it conducts electricity. So weak electrolytes are typically organic compounds like carboxylic acids and amines. Non-electrolytes don't conduct electricity at all, even if they do dissolve in water. So these are typically organic compounds like sugar, okay, carbohydrates. Keep in mind here that the words strong and weak only have to do with how well something dissociates and it forms ions to conduct electricity, not at all with how dangerous or reactive something is. Okay, for example, HF is considered a weak acid, okay, because it doesn't dissociate very well. However, HF is extremely dangerous. Okay, it, for example, can leach all the calcium away from your bones and lead to things like osteoporosis. And it'll actually also etch glass. Okay, it can actually react with glass, whereas most things don't. Yet it's considered a weak acid because it doesn't dissociate very well. So now, how do you know what the concentrations are going to be of these different ionic solutions? To figure out the concentrations of these ions, I need to think about 2 things. One is what the formula is, so I know what kinds of ions are present, and how many of them I have. And I also have to worry about whether or not it dissociates completely, as in a strong electrolyte. For purposes of the CLIP exam, we're going to assume that everything is a strong electrolyte and dissociates completely. They're not going to ask you to calculate anything for weak electrolytes or non-electrolytes. So this makes your life much easier. You only have to look at the formula and see how many ions are present. So for example, something like NaCl only has two ions in it, right? Sodium ions and chlorine ions. And something like barium chloride also only has two types of ions in it, but when it dissociates, it forms barium ions and two chloride ions. So the total number of ions would really be 3. So this is why I have to factor in both the formula and whether or not it dissociates completely, right? If I just know the types of ions, it's not really just enough to solve these problems.